video, we're going to take a look at a two-sample t-interval. So the idea is we have some population that has a center, an average, a mu. We have another population that has a center, a mu, right? And what I'm trying to do is I don't know those mu's. I'm trying to estimate the difference between those two. So I have some population center, some other population center, and I'm finding the distance or the difference. So I'm going to take one minus the other, and I'm trying to estimate roughly what is the distance between the two, which to find the distance, you're going to find the difference. Take the larger one minus, say, the smaller one, okay? Ideas of what a two-sample t-interval will be a little bit more fleshed out here in this example. So here we go. Some AP students wondered what the difference in average weights there was between high school and middle school students. The AP students selected a simple random sample of 100 high school students and found their mean weight was 175 pounds with a standard deviation of 15 pounds. The group also collected a simple random sample of 100 middle school students and found that their average weight was 130 pounds with a standard deviation of 8 pounds. Construct and interpret a 95% confidence interval for the mean difference of weights of high school students versus middle school students. So this group just wants to know how much more do high school students weigh on average than middle school students. So I don't know the average weight of all high school students. I don't know the average weight of all middle school students. If I did, I would find a difference and say, hey, on average, the difference is this. So that's what we were trying to estimate, that roughly, hey, the average weight is between here and there. That true difference is somewhere inside of our interval. So I already worked through this problem for us to try and speed things up, but I'll explain the process I did in the order. First thing I did is I pulled out relevant information. Sample size from population 1, N1 is 100, X bar 1, so that average of that sample is 175, standard deviation of 15. For my second population, N2 is 100, X bar 2 is 130, S2 is 8. So I pulled out relevant information first. Because I'm doing a confidence interval, I then worked myself through PANIC, P-A-N-I-C. So start with the parameters. I have two population parameters. Mu1 is the mean weight of high school students, and Mu2 is the mean weight of middle school students. So the mean weight of high school students, the mean weight of middle school students. So Mu1 and Mu2. The assumptions here, So before you can actually do a confidence interval, we need to make sure certain things are happening with my sampling distributions, and then we can work through some assumptions. So we need these things to be in order to make sure the formulas, everything is going to actually work out. Three things we're going to check with mean problems. We're going to check n dependence, 10%, and check with n is greater than or equal to 30. But we have to check that for both of our samples that we got. So n dependence, both samples, or the samples were both simple random samples. The sample of high school students, sample of middle school students were both simple random samples. That's going to help with independence. 10%, each sample is less than 10% of their population. So the sample of high school students is less than 10% of all high school students. The sample of middle school students is less than 10% of all middle school students. That 10% rule is helping us with independence. Our third one is making sure our sample is big enough. So we're going to check n is greater than or equal to 30. So we're checking if each sample is large enough, whether each sample is large enough. Each sample size was 100. I know I'm blocking the other one, but each sample size was 100, so both of them are big enough. So with these things, we know our sampling distribution is approximately normal. It's going to allow us to actually go through and use the formulas for a confidence interval. So because of these assumptions, I know I can do a two-sample t-interval, So what we have here is I went ahead and went through my formula, x bar 1 minus x bar 2, so 175 minus 130, plus or minus my t star. I'll talk about that again in a second. And then the square root of s1 squared divided by n1 plus s2 squared divided by n2. The calculator gave me my degrees of freedom and says it's 151.10. So what I did is I used a t-table. I found the closest thing I could get to the interval, the 2 degrees of freedom between 151, which is degrees of freedom of 100, degrees of freedom of 1,000. And I picked which one gave me the larger t star for a 95% confidence interval, which is 1.984. So doing all this, my calculator tells me, hey, this interval is from 41.64 to 48.36. So I left it off here. I'm going to wrap it up, though, as we can now do our context. So pulling this all together and explaining what does this mean. So what we say is we are 95% confident the true mean difference of weights of high school students to middle school students. I'm going to add a little bit here. I did high school minus middle school. Make sure that's really clear. Is between 41.64 and 48.36 pounds. In other words, if I knew the average weight of all high school students and the average weight of all middle school students, and I could subtract those, take the average weight of all high school students, subtract off the average of all middle school students, that difference is going to fall. I'm 95% confident on this. It's going to fall somewhere between 41.64 pounds and 48.36 pounds. So this is a 2-sample T interval. Make sure you have all your pieces here, your P, A, N, I, and C. Be very careful on the formulas, notation, all of those things. Again, this was a 2-sample T interval.